Hi, I'm Yusuf. Welcome to the second session of our MindSpore Tech Day.
And I'm Rachel.
Welcome here, Rachel. How's your vacation?
Had a lot of fun. Alright, let's cut to the chase. We have a lot to cover in today's live streaming. We will see how advancements in the past decade have created a new wave of algorithms in machine learning, especially deep learning.
Behind this wave are a wide variety of deep learning tools and frameworks, which are designed to convert complex mathematical formulas into recognizable computing graphs for the object classification, speech recognition, and other fields.
In this session, we will discuss AI frameworks in terms of the technologies, development history, application scenarios, and future trends. Remember, this live stream is meant to be interactive, so later we will prepare Q&A session, and we'll be appreciated if you join our quiz game.
Now, let's jump right in. AI framework is a hot research topic in the deep learning field. But what are AI frameworks? Why do we use them in the machine learning field?
Generally speaking, an AI framework is a software package used to design and train deep learning models. They allow people to train new models without having to work with the underlying algorithms, deep learning, neural network, and machine learning.
These frameworks provide building blocks for designing, training, and validating AI models for over a programming interface. Most mainstream option uses GPU-accelerated libraries such as QDNN and Nickel to deliver high-performance, multi-GPU accelerated training. Typically, AI frameworks have been tightly coupled with AI development, and it's this relationship that has propelled a rapid development of frameworks, models, and tools.
The frameworks supply readily available libraries for defining layers, network types like CNNs, RNNs, and a common architecture, simplifying development in computer vision, natural language processing, and other machine learning fields.
In addition, they host interfaces of popular programming languages such as Python, C, C++, and Scala.
Much like our evolution from the Stone Age to Industrial Age, AI frameworks have similar periods of development.
That's right. These phases can be loosely defined in modern AI.
Before the early 20s, there were only a handful of tools that could describe and develop neural network. But these tools were not tailored to neural networks model development, adopted complex user APIs, and didn't support GPUs.
Naturally, developers had to do a lot of heavy lifting with these primitive AI frameworks.
That's right. They needed to not just manually design the backpropagation algorithms and optimizer, but also set up a network architecture.
Much like we moved from the Stone Age into the Bronze Age, technological innovation propelled the development and technological progress of AI.
In 2012, Alex Krikowski proposed a deep neural network architecture later known as AlexNet. In the 2012 ImageNet Large-Scale Visual Recognition Challenge, this network achieved a top 5 error of 15.3%, more than 10.8 percentage points lower than that of the runner-up.
Considering its position as an early convolutional neural network architecture, AlexNet achieved state-of-the-art accuracy on ImageNet dataset. It is likely this outstanding result must have sparked the excitement in the deep neural networks.
This time was also the early days of other AI frameworks such as Caffe, Theno, and Trainer. Caffe and Theno use a declarative programming style, while Trainer adopts the imperative programming style. These frameworks help build complex deep neural network models such as CNN, RNN, and LSTM, and also support multi-GPU training. Compared to the previous frameworks, this significantly reduced the time needed to train models, but more importantly, enable training of large models that couldn't fit into a single GPU memory.
So, for our audience, what do we mean by declarative and imperative programming style?
Well, they are programming paradigms that are used to solve problems using common programming languages. Put simply, the imperative programming describes the control flow of computation, while declarative programming expresses the logic of computation. These two distinct programming styles also signaled two different development paths for new AI frameworks.
Time for our first question. Multiple answer. What are the features of imperative programming and declarative programming? Imperative programming describes the control flow of the computation, or declarative programming describes the control flow of the computation. C. Imperative programming describes the logic of the computation. And lastly, declarative programming describes the logic of the computation.
Okay, let's see who will win.
You gotta try hard. You gotta write your comment down there.
But how many times do we left now?
It's almost
5.
5 seconds right now. 4,
Okay.
3,
2,
2, 1.
Okay, we have a winner. The correct options are A and D.
Next, we are going to discuss further advancement in recent years.
Yep, much like how production of iron advanced and replaced their bronze equivalents, newer technologies pushed the next stage of AI frameworks evolution. The success of AlexNet reignited new interest in computer vision and neural networks, emboldening large tech companies to develop deep learning frameworks.
One such company was Google, who open sourced the famous TensorFlow framework, which is still the most popular deep learning framework in machine learning field up today. Similarly, Microsoft Research Development CNTK and Amazon adopted MaxNet. Other examples are Facebook, who is the inventor of Caffe to release Caffe 2, while Facebook AI Research or the FAIR team released another popular framework, PyTorch, which was based on Torch framework but adopted popular Python APIs.
This market became hugely competitive, with each brand wanting to win a first place in AI framework competitions. So, Yusuf, do you know which frameworks gained the most popularity?
I do. In 2015, I witnessed the birth of ResNet, a residual neural network that set new records in ImageNet accuracy and pushed the boundary of image classification. While both ResNet and AlexNet performed well in ImageNet classification, AlexNet is a convolutional neural network, or CNN, with 8 layers of learnable parameters, 5 layers that combine max polling, followed by 3 fully connected layers, while the main base element of ResNet are residual blocks. A residual block is a stack of layers in such a way that output of the layer is taken and added to another layer deeper in the block.
The cutting-edge performance of both networks led to a consensus across and academia that deep learning was the next big trend, and that with it, we could solve the biggest challenges in various fields.
Around this time, AI frameworks were polished to provide clearly defined APIs and optimized for multi-GPU and distributed training. It spawned many toolkits that targeted specific tasks such as computer vision and natural language processing. The key result of this competitive market created a duopoly of 2 big empires, TensorFlow and PyTorch. These 2 models comprise 95% of the use cases of deep learning framework in research and production.
TensorFlow is developed by Google Brain and actively used at Google both for research and production needs. While suitable for a wide range of tasks, it excels in training and inference of deep neural networks. PyTorch is a cousin of Lua-based framework that was developed and used at Facebook.
Both TensorFlow and PyTorch provide useful abstraction to reduce boilerplate code and accelerated development. TensorFlow is a powerful and mature framework that supports mobile platforms and has strong visualization capabilities, making it perfect choice for high-level model development. PyTorch is still a young framework, but one with a huge moment. It has more developer-friendly and allows you to define reusable modules for object-oriented programming.
TensorFlow is a good option if you want to develop models for production or for mobile platforms or need to perform large-scale distributed model training, and you may want to use PyTorch if you want a premium and flexible debugging experience.
That's right, if you are thinking of developing a new AI modules. Our advice is to try both frameworks and see which best fits your needs.
Deep learning has already transformed many processes in fields like self-driving, personalized recommendation, natural language understanding, and healthcare. And what's more, this popularity has brought an influx of users, developers, and investors.
The coming decade is expected to be golden time for deep learning tools and AI framework. Since 2020, there have been two main trends in the AI framework space. First, the large model training, which is the birth of BERT and its transformer-based relatives such as GPT-3 training large models become the must-have requiring the AI framework to train efficiently at a scale up to hundreds or thousands of devices.
The second trend is usability. Most AI frameworks from this period adopted the imperative programming style because of the strengths in flexible semantics and easy debugging. These frameworks provide user-level decorators or APIs to achieve high performance through just-in-time compiler techniques.
Question 2. Okay, multi-answers. Fingers on the buzzers. What are the two main factors that have driven the development of AI frameworks since 2021? A. The automatic diversion function. B. The increasing model size. C. The demand on usability of the AI framework. And lastly, the demand on quick deployment of the AI framework. Go, 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 go!
Okay, let us see who's gonna be
Our next winner.
Okay, the right answer is, of course, B and C.
One major framework in recent years is MindSpore. Developed by Huawei, it implements on-demand collaboration across cloud, edge, and device. It provides unified APIs and end-to-end AI capabilities for mode, development, execution, and deployment.
Using it, a distributed architecture, MindSpore leverages a native differentiable programming paradigm and new AI native execution modes for premier resources efficiency, security, and trustworthiness. It fully uses the computing power of Ascend AI processors and lower the entry requirements for industry AI development, making inclusive AI a reality.
Most AI frameworks are far from mature, especially when compared to programming language, Java, C++, and the development of the internet applications. That said, there is still a lot of exciting opportunities yet to be explored.
New AI is emerging every year. revolutionizing many human endeavors from writing to coding to drug discovery. As AI has entered its industrial age, I'm looking forward to seeing how far AI frameworks can go.
Improvements in the productivity have driven the evolution of human civilization. Similarly, with the improvement of AI technologies, the AI framework has also formed a relatively complete technical system. The core mainstream AI frameworks is divided into three layers: the foundation, component, and the ecological layers.
The foundation layer implements the most basic and core functions of AI framework and comprises three sub-layers: programming, development, compilation, optimization, and hardware enablement.
In terms of programming development, APIs and languages are key resources for building AI models. APIs offer high usability and flexibility that is crucial in computational graphs. Generally, programming interfaces are classified into three types: DFD based, like those adopted by TensorFlow; layer based, like those used by Caffe; and algorithm based interfaces adopted by scikit-learn.
That's right. In addition, a mature AI framework must support diversified programming languages such as Python, Julia, Char for new application. The compilation optimization sublayer is responsible for optimizing AI models and scheduling computing resources using key technologies.
Now, let's discuss computation optimization for a while. As deep learning is rolled out in various fields like computer vision, language understanding, and speech recognition, a common feature is the growing size of models. For example, GPT-3 model, which has 175 billion parameters, but even so, the full training time using GPT-3 would take a month.
Enlargement of model scale requires better hardware. However, because of the limitation in memory walls, computing power, and capacity, it is more difficult than ever to integrate chips and keep up with the demands of model expansion.
Simply increasing number of data sets and parameters causes bottlenecks. In this case, distributed training is necessary, but this requires both multiple devices to perform computing but also data transmission between devices.
Common parallel strategies include model, pipeline, data, optimizer, and hybrid parallelism. Each choice will have a different effect on training. To improve efficiency, future AI frameworks should allow developers to adopt different parallel strategies.
With probabilistic models and algorithms becoming more complex, computing derivative is now a formidable task. In many cases, we cannot calculate derivatives analytically, but only evaluate them numerically at certain points.
So, we need a powerful method to differentiate mathematical functions and algorithms. That brings us to automatic differentiations, a set of techniques designed to automate the calculation of derivatives. Especially, it evaluates the derivative of a function specified by a computer program. This is possible because every computer program executes a sequence of elementary arithmetic operations: addition, subtraction, multiplication, division, etc., and functions.
Stop it. You are making me remember my math class. So, assuming AD helps in calculation, the entire training process is simplified, right?
I think so. By repeatedly applying the chain rule to these operations, derivatives, arbitrary order can be computed accurately.
Another important direction of compilation optimization is to support switching between static and dynamic graphs, which are execution modes of mainstream AI frameworks.
TensorFlow builds a static graph before execution to define all operations and network structures, improving train performance but at the cost of usability. By contrast, PyTorch adopts dynamic graph computing that is executed immediately. Different from static graphs, dynamic graphs are more flexible and easier to debug, but performance is limited.
Due to these disadvantages, existing AI frameworks cannot meet the requirement of easy development and efficient execution. To fix this issue, TensorFlow 2.0 and MindSpore are optimized to support switching between dynamic and static graphs. To provide flexibility and improve computing efficiency.
AI frameworks must support operator computing, but one major issue is that varying levels of workload and complexity for each operator. For advanced operators that require a huge amount of computations, it is hard to improve their performance, whereas those with small amounts may cause calculation latency. In short, neither can make full use of devices' resources.
To address this problem, AI frameworks use tensor-based high-level IR to process and optimize graphs, and instruction-based low-level IR to analyze, tune operators, but these operations are separated, hindering optimization of graphs and operators.
This brings us to graph kernel fusion. It is designed to analyze and optimize the computation, graph logic of existing networks, as well as split, reconstruct, and diffuse the original computing logic. This reduces overheads of operator execution, gaps, and improves the device resource utilization, a circulating execution of the network. So earlier, we mentioned that memory wall can affect performance of large-scale models.
The memory resources of AI chips are limited, and many issues can arise if the memory is not used efficiently.
That's why memory optimization is needed to improve performance. This optimization of memory resources resolves such issues such as memory block overrides and insufficient memory API usage. Common optimization methods include static memory overcommitment and dynamic memory allocation.
But what are these methods specifically?
Well, static memory overcommitment analyze the data flow relationships among computational graphs to minimize the memory usage. According to the occupied data memory lifecycle overlapping between data and memory reuse policy of the data to be used, the dynamic memory allocation mechanism creates large memory blocks and destroyed memory slices after operator execution.
In most cases, AI framework allows common operators, but the operators cannot meet the requirements of algorithm evolution. Therefore, AI frameworks must be able to generate, unify, and optimize underlying operators for devices with varying level of computing power.
This greatly reduced the development and maintenance costs of the AI framework and hardware platform.
The final sub-layer of the foundation layer is hardware enabling. Basically, this means AI frameworks should support compute operators and communicative operators. A compute operator can be taken as a function node in a computational graph responsible for running all computer operators, while communicative operator serves as a function node used as communication between distributed nodes which is critical to distribute training.
The next layer of AI frameworks is the component layer. It mainly includes high-level functional components, including those for parallel computing and optimization, scientific computing, and security, which are integrated throughout the AI model lifecycle to optimize performance at different layers.
The parallel and optimization components support various combinations of the automatic parallel technologies. AI frameworks allow developers to combine multiple parallelism types to form hybrid policies, for example, combining data parallelism with model parallelism to support flexible AI model training and configuration. It is also support various first and second order optimizer, such as SGD, SGDM, and ADAM to provide flexible and easy to use APIs.
One of the important fields of AI development is scientific computing, one of three pillars of science, alongside theoretical analyses and experiments. In practice, computer simulations solve problems in various scientific disciplines. It is often used in combination with other forms of computation, such as numerical analysis and theoretical computer science.
Different form of confusional theory and laboratory experiments, the scientific computing approach is to gain understanding through the analysis of mathematical models implemented on computers.
That is to say, once again, math is a key to computational science.
That's right. The AI framework provides functions related to scientific computing to facilitate programming in a manner that resembles mathematical computing. To be specific, the AI framework needs to convert the input data into convolutional scientific computing, for example, the generated by convolutional software into tensors. This requires not only a unified data engine, but also the support of convolutional numeral computing methods, such as high-order differential analysis and linear algebra computing.
Correct. Scientific computing is all about applying algorithms and theory. For example, the MindSpore ELAC is a framework designed by our expert team. It is equipped with built-in MindSpore science components to solve issues in the electronic information industry. Additionally is MindSpore Sponge, our model built for life science that boosts electromagnetic simulation tenfold and simulation efficiency of biopharmaceutical compounds by 50%.
AI has the potential to revolutionize existing practice in work and daily life. But with it comes new security and privacy protection concerns. Therefore, AI frameworks must prioritize security, including data security and model security.
Just imagine the impact of a data breach. Its consequences include financial loss, reputational damage, operational downtime, and loss of sensitive data. That's why data security protection for AI is so critical.
When designing AI algorithms, security threats must be considered. Otherwise, the developed AI model may easily be attacked by malicious viruses, leading to inaccurate judgment of the AI system. Even the smallest perturbation to the original sample, so small they are imperceptible to humans, can cause deep learning model misjudgment.
Data security includes protecting raw data and preventing information leakage. As for model security, if samples are not fully trained during model training, the model may have worse generalization capability and cannot generate correct results.
In addition, AI frameworks need to protect the privacy model data. Common methods include black box and white box tests and network distillation to improve robustness of AI models.
Robustness of AI models? You've lost me. Maybe you can explain what this means to our audience.
Well, essentially, AI models can encounter adversity from two ways: identical, such as corrupted data, and unintentional, such as hackers. Both can mislead a model into delivering incorrect prediction or results. Adversarial robustness then refers to a model abilities resist of being fooled.
So the key to protecting AI models is to make them more robust to adversity.
Exactly. Improve the robustness, and you will improve your model's ability not to be fooled.
Phew, that was intense. Let's see if you were paying attention. Which statement about scientific computing is true? Okay, A. It is known as second pillar of science, standing right next to theoretical analysis. And B. It emphasizes experiments performed on a computer. C. It is used to gain understanding through the analysis of mathematical models implemented on computers. And D. The essence of scientific computing is to apply numerical algorithms with computational mathematics.
3, 2, 1. Go! Just leave your comment down there, and we will contact you through our email.
Yes. Do we have a winner now?
I think we already have one. Let's see who
Okay.
is he
Yeah.
or she.
So what was the correct answers?
Okay, time is up. The correct answers are C and D. Our next layer is the ecosystem layer, oriented to services. It consists of documentation and communities, as well as tool and models libraries that provide toolkits, pre-trained models, and defined model structures used for AI model training and interface.
Documentation relates to framework description, APIs, features, and common operations to help users get started and guide them to develop applications on the framework.
For sustainable development, many users choose to upload and develop projects open source on third-party platforms such as GitHub and Git. This means anyone can browse and download public repositories, and registered users can have discussions, manage repositories, submit contributions to others, repositories, and review change to code.
And some open source projects even can help promote the capabilities of AI frameworks. Developers are charged with maintaining a harmonious community to continuously attract new talent. This critical process will promote development in AI framework.
AI frameworks adopt core technical advantages that have been used throughout scientific research. For example, AI technologies are used in genomic data to predict protein structures in drug discoveries, build models to track climate variabilities for weather, and find patterns in satellite images, environmental conservation.
Rainforest Connection is a non-profit technology startup that generates real-time data on deforestation activity in tropical rainforests. It recently adopted the Build TensorFlow framework to build the world's first scalable real-time detection and alert system for logging and environmental conservation in the rainforest.
So, despite laws authorization logging in designed areas, illegal logging in widespread in Brazil and other countries. A study by Brazilian Commission showed that 80% of all logging in the Amazon was illegal during the late 90s.
Illegal logging is a global problem with significant impact. It not only results in lost revenues and other foregone benefits, but also can be linked to conflicts over land and resources. the disempowerment of local and indigenous communities, corruption, and more.
By monitoring sounds in the forest, the TensorFlow framework runs on specialist small-scale devices to transmit all audio to our cloud-based service over the standard local cell phone network. Once the audio is in the cloud, TensorFlow is capable of analyzing in real time and listening for sounds of the chainsaw, logging tracks, and other illegal activities.
Without the help of the AI framework, such as work would be impossible. When fighting deforestation, every improvement means one more saved tree. To prove this strength, let's discuss another piece of news. A MindSpore-based model chopped protein structure prediction competition for 3 consecutive weeks in 2021.
3 consecutive weeks?
That's right. AlphaFold is the benchmark due to its cutting-edge performance in protein structure prediction. In November 2021, Huawei jointly launched a tool for protein structure prediction and inference that runs on the algorithms of AlphaFold 2, and that was refined again in February 2022 to improve the efficiency by 2 to 3 times.
Protein structure prediction is one of the key studies of AI in life science and is of a great significant topological research, but it is hard to make progress in protein structure prediction as convolutional prediction methods are oftentimes plagued by inaccuracy. That's why the high accuracy and speeds of MindSpore are outstanding.
The MindSpore-based tool can calculate the protein structure of a sequence of over 2,000 amino acids, covering upwards of 99% of protein sequences, implemented on the Ascent AI software and hardware platform. It enables mixed precision, slashing single-step iteration from 20 seconds to 12 seconds, and increasing performance over 60%, making it invaluable to bioprotein research and new drug discoveries.
In addition, AI frameworks are closely integrated in stellar activities.
You mean like searching for extraterrestrial life?
Well, not quite, but it did help NASA to identify the Kepler 90I and exoplanet with potential habitat life.
I heard Professor Brian Cox say that there are 100 billion stars in every galaxy and there are over 2 trillion galaxies. Can you imagine the amount of astronomical data? How did NASA find the planet in so many stars?
Yes, well, a key challenge is astrological research is to sieve through and deduct interesting features of signals from all the data and to assign these to a specific category or phenomenon. NASA uses TensorFlow to deduct signals at a border range and analyze accumulated data during the Kepler mission.
Well, there you go. Without the AI framework, we may never complete the Kepler mission, and we might have missed out an important discovery in astrophysics.
Advancement in technologies have allowed researchers in multiple domains analyze large data sets to detect previously unforeseen patterns and extract new insights.
AI frameworks are also important to developing AI applications because they schedule computing resources of hardware and support model building for upstream AI applications.
A standard off-the-shelf AI method is just not suitable because each branch of science has very specific challenges and requirements. The first is the compiler-based operator optimization. Today, many operator kernels are implemented either manually or via third-party libraries that align to a specific hardware platform. But Overhead occur when the model is trained or developed on different hardware platforms.
In addition, the growth of new deep learning algorithms is much faster than the iteration of these libraries, causing new operators to not be supported by these libraries. Deep learning compilers such as Apache, TVM, MLIR, and Facebook Glow and designed to optimize and run computations efficiently on any hardware backend. They are well positioned to serve as the entire backend stack in the AI frameworks.
Second is unified API standards. Many AI frameworks share similar but slightly different user APIs, making them difficult to use and creating unnecessary learning curves when switching from framework to another.
Because of its familiarity with many machine learning practitioners and data scientists, the NumPy library became the natural standard for tensor manipulation APIs in the new deep learning frameworks. A good example is the rapidly growing framework JAX, because JAX APIs are compatible with NumPy.
The final challenge to discuss is to make data a first-class citizen. Consider how multi-node or device training is the norm of deep learning network training. Recently developed AI frameworks such as OneFlow leverage this insight from day one and treat data communications as part of the overall computation graph of the model training.
This practice opens the door to more opportunities for performance optimization. And since such models don't have to maintain multiple training strategies like previous AI frameworks, it can provide a simpler UI and better performance.
AI engineering is a hot research topic. It is an emergent discipline covering development tools, systems, and process to apply AI to real-world environments. A robust AI engineer strategy will facilitate better performance, scalability, interoperability, and reliability of AI models.
Since 2020, Gartner, the top research and consulting firm, stressed the value of AI engineering in its top strategic technology trends report. They predict new AI engineering technologies will help enterprises earn 10% more profits.
We can see how companies using premium AI engineering technologies will lead to the future development of AI. But what role does the AI framework play in this trend?
Well, AI frameworks must support quick porting of AI models to different platforms to facilitate quick deployment for diversified tasks in one scenario or one task in various scenarios.
Also, it should support incremental training on the device or edge side to further improve the training efficiency. It may be difficult, but once the conditions are met, the AI framework will be easily produce AI products with practical value.
Earlier, I mentioned two aspects: large-scale model training and usability. The birth of the OpenAI GPT-3 model popularized foundation models. A foundation model is a large AI model trained on a vast quantity of unlabeled data at scale. With 175 billion parameters, the GPT-3 model is a big leap forward. But this beaten by Huawei Pangu, whose 207 billion parameters run and are trained on the MindSpore framework.
207 billion. That's insane.
Foundation models are one major reason in how AI systems have evolved. Because foundation models rely on big data and powerful computing power, AI frameworks must overcome challenges in the memory allocation, computing power scheduling, model tuning, and deployment, and communications among nodes.
Okay, final question of the day. we just introduced technological evolution and challenges of the AI framework. How can AI frameworks support the future development of AI technologies? A. Support the quick deployment of AI models. B. Improve the robustness of AI models. C. Support the training of the large-scale models. And lastly, increase the training efficiency.
Enter your answer in the chatting box now.
Only 5 seconds left.
Who knows? Okay, let's have a look. So we have our last winner.
Please send your information to our email address. Improving AI frameworks from technological standpoint can only go so far and must be combined with effective promotion methods. The global AI framework is booming and the trend diversified competition and cooperation is become more and more pronounced.
The global AI framework open source ecosystem is more activate than ever, which is important to future development. Statistics on GitHub reflects the popularity of each AI framework in the industry. TensorFlow and PyTorch rank first and second place, demonstrating their popularity.
Open source communities are perfect for AI framework developers, allowing them to submit commits to the communities and collaborate on new projects.
When the Google TensorFlow team open-sourced its framework, many developers became contributors or managers to the TensorFlow community, submitting advanced API code and sharing their experience in developing TensorFlow-based projects. This symbiosis helps explain why TensorFlow is the top open-source framework.
Therefore, building and maintain a quality open source community will provide new talent with the opportunity to innovate new projects, while also advancing existing AI frameworks, products, and solutions.
Cooperations between universities, research institutes, and enterprises is another way to expand the value of AI framework. The strong talent and lab resources of universities and institutes will inject more momentum to the development of the AI framework.
Cultivating a new generation of AI talent is a key for the entire AI ecosystem. For example, Huawei launched several projects to provide MindSpore tutorials in universities and colleges. This has clearly made an impact as according to papers with code, MindSpore-related papers accounted for 10% of all papers about AI frameworks.
Academic papers lay a foundation for enterprises incubate new AI technologies and implement AI projects. Through cooperation of all parties, we will help build new models that will reframe conventional work around the world.
We are at the dawn of an AI revolution. New research and application in AI are generated at unprecedented pace. 12 years ago, AlexNet network contained 60 million parameters. Fast forward 8 years, the GPT-3 network contained 175 billion parameters, 300,000 increase in data. Human brains, on the other hand, contain an estimate 100 trillion parameters, indicating a huge gap for neural networks to reach human-level intelligence.
This is the next great challenge for efficient hardware-software computation for model training and inference. Future AI frameworks are likely to combine algorithm, high-performance compute, hardware accelerators, and distributed systems. But we will discuss that more next time.
In the next episode of MindSpore Tech Day, we will talk about MindSpore, an AI-powered framework developed by Huawei, and how it supports with Ascent processors and multiprocessor architecture.
That's right. With its friendly design, efficient running, and flexible deployment, MindSpore is redefining AI frameworks, making it a perfect option for developing AI software and hardware ecosystem.
That's all for today. Thank you for watching and see you next time.
See you.